Welcome to qnawire.
So now we're going to work on problem 77 from chapter 13. In this problem, we're told that we're making an antifreeze mixture by mixing equal volumes of ethylene glycol and water. So we're given some information, the density of ethylene glycol and water and the molar mass of ethylene glycol, and we need to calculate volume percent, mass percent, molarity, molality, and mole fraction. We're also given the density of the mixture. So we're going to need several different parameters to calculate all these concentrations. So first, we should calculate the mass of ethylene glycol. So we're told that they mix equal volumes of this ethylene glycol and water. It doesn't tell us what the volumes are, so we can select something that's convenient. So we can choose 1 liter for each volume. So 1 liter of ethylene glycol. And we can convert this to mass first by converting to milliliters, because the density value is given in grams per milliliter, and then multiplying by the density. So milliliters and liters cancel, and we get a value of 1114 grams of ethylene glycol. So next we can calculate the mass of water. The volume that we're given, or the volume that we chose, is 1 liter. We go through exactly the same process. The value of density that we're given for water is 1.00 grams per milliliter. So 1 liter of H2O is 1,000 grams of H2O. So to calculate all these concentrations, we're going to need moles of each of these solutions, each of these constituents of solutions. So moles of ethylene glycol is equal to the mass, which we calculated, times the molar, or divided by the molar mass, which is 68.02. So we have a value of, it's 62.07. Read from the problem incorrectly. And so that gives a value of 17.947 moles. We can do the same thing for water. We have a mass of 1,000 grams. We divide by the molar mass, which is 18.02 grams per mole. And we get a value of 55.494 moles. And then finally, we can calculate the volume of the solution. At first, this might seem a little unnecessary because we selected our volumes at the beginning. 1 plus 1 should be 2. But we're given a density of the final solution, so we can go ahead and double check. Our total, we can multiply our mass of solution, which the mass is not going to change upon the addition of the two species together. So we add these masses together, and then we multiply them by this density. 1 milliliter, or we divide by the density, 1 divided by 1.070 grams per milliliter, and it gives a value of 1.976 liters. So the volume is not additive like the mass is. So the volume is reduced a little bit from what we would expect. So the first concentration that we need to calculate in terms of ethylene glycol is volume percent. So this is equal to volume of ethylene glycol, which we measured as 1 liter, or we assumed as 1 liter. And then the total volume of the solution is 1.976 liters, which we just calculated here. And so we multiply this by 100. And we get a value of 50.61% volume by volume. The second is mass percent. So our calculated mass of ethylene glycol was 1114 grams up here. And then our total mass would be just 1114 plus 1,000 grams is what we calculated for water. And so we have to multiply by 100 because this is percent. And we calculate that it should be 52.7% by mass by mass. Or you may see weight by weight. In part C, we have to calculate molarity. So we need moles of our solute, which is ethylene glycol, which is here, 17.947 moles. And then we need to divide by our volume of solution, which is 1.976 liters. And we get a value of 9.08 molarity. In part D, we calculate molality, which has the same number of moles in the numerator. And then we want to divide by our mass of solvent, which is 1,000 grams or 1 kilogram. So our molality is 17.9 small n. Finally, in part E, we want to calculate mole fraction. So we have 17.947 moles of ethylene glycol divided by the total moles, which is 17.947 plus the moles of water, which is 55.494. And this value is equal to 0.244.